In Lecture 4, we will discuss the physiology behind erection and ejaculation. The mechanism for erection is the same for both females and males. And I want to start off by first introducing the players involved in erection. So you have the CNS, which sends a message to a parasympathetic nerve, which then communicates to the smooth muscle cells that are located around the arteries that control blood flow into erectile tissue. Now, there are two parts of an erection. First, you must initiate the erection, and this starts in the brain by thinking erotic thoughts or sensing something erotic with your special senses. For example, seeing or hearing something that is sexually pleasing to you, and that will stimulate the release of oxytocin as a neurotransmitter to stimulate the release of glutamate, which you know is an excitatory neurotransmitter. Now, glutamate is going to bind to the parasympathetic nerve to signal calcium entry, which activates calmodulin, which stimulates the release of a neurotransmitter called nitric oxide. So let's write this down. Nitric oxide. Now, nitric oxide is a new player, and it should not be confused with nitrous oxide, which is laughing gas, okay? But what nitric oxide does is it binds to smooth muscle cells, and it'll activate guanine cyclase to make cyclic GMP, which closes calcium channels, and it downregulates MLCK, which now causes downregulation of contraction and allows vasodilation to occur so I can fill the erectile tissue with blood. Now, I've started my erection. The second part of the erection is to maintain it. And so the same structures are involved in maintaining an erection. Now, as the smooth muscle cells start to stretch because of increased blood flow, it's going to start to signal the CNS to turn on a very important person called VIP, which stands for vasoactive intestinal peptide. And it's called an intestinal peptide because that's where it's first found, okay? But VIP binds to the parasympathetic nerve and it stimulates, again, nitric oxide release, which will, of course, bind to its receptor to turn on the same processes that I've already delineated up here to keep vasodilation going. To sum up, oxytocin and glutamate from the CNS are going to turn on the parasympathetic nerves during the initiation of erection, which releases nitric oxide that turns on vasodilation. As soon as I start to have vasodilation, the stretching of smooth muscle cells will signal the CNS to release VIP, which also turns on parasympathetic nerves to maintain the erection via the same mechanism. And in order to have vasodilation, you must turn on parasympathetic nerves. So you must be relaxed and not anxious. Okay, because upregulating the sympathetic nervous system causes the erection to go away. All right, now if you want to maintain the erection, and this is for men and women, okay? Ladies, you have a penis. It's called the clitoris. You have to keep secreting oxytocin, glutamate, and VIP. You have to. And the reason being is, now I'm just going to take cyclic GMP up here, right? And I'm going to redraw it down here so I have some space. So you know that in order to vasodilate, you need cyclic GMP. However, remember, in the cell, we are constantly turning things on, but we have to be able to turn things off. They are just two sides of the coin, both important. Upregulate and downregulate, and they're happening at the same time. So what's happening in the cytosol of the myoepithelial cells in the smooth muscle is that you have now cyclic GMP. However, it's constantly getting degraded. And we talked about this in the beginning of the semester, like for 10 seconds. So I don't expect you folks to remember this, but cyclic GMP is constantly getting degraded to GMP. And this GMP is inactive. It does nothing. It's a waste product. Inactive. Okay? And it's doing so via an enzyme that's in the cytosol all the time called PDE. This is a P. Okay? Which stands for phosphodiesterase. Okay? So it's an enzyme that's just constantly breaking down cyclic GMP into its inactive form, which means you have to constantly be making more GMP, cyclic GMP, the activating molecule in order to maintain that vasodilation. Okay? All right. That's it for erection. Let's ejaculate. All right, so the players for ejaculation, of course, are the central nervous system. And then we have myoepithelium around all the ducts. So this can be the seminiferous tubule, the vas deferens for men, and for ladies. I shouldn't say that because that's very binary. If you have a seminary ducts and a vas deferens, you have myoepithelium around those ducts, and those ducts are lined with endothelium. So endothelium is the tissue lining the lumen, and then you have muscle surrounding it, right? Ladies, crap, I did it again. If you have a uterus, fallopian tubes, vagina, this is the same anatomy, right? So you have myoepithelium all around and endothelium inside, right? Because the vagina, the uterus, they're all modified ducts. And so that's the anatomy, right? So here, when you have tactile stimulation, right? This is post-erection. So erection first, then tactile stimulation. You're going to have now receptors go and feed back to the central nervous system, right? And then you're going to secrete oxytocin again, but this time it's a little bit different. This is not a neurotransmitter because it gets secreted into the bloodstream, okay? There's no peripheral nerve here. We're going straight from the CNS right to the periphery. So here, oxytocin now as a hormone is going to bind. And we know that oxytocin is contractile, right? It's going to cause smooth muscles to contract. And this is the mechanism. And you folks already memorized this, I hope. Or maybe you forgot it, but this is all the same, right? I activate PLC. PLC is going to turn on the upregulation and release of IP3. And you folks already know IP3's job is to bind to all the calcium gates and let calcium in to the cell, the muscle cell. Right? Now, remember, this is smooth muscle. So I have to activate calmodulin. And then calmodulin can activate MLCK, which is a kinase, which you folks know is going to phosphorylate all the muscle, myosin heads. It's going to allow me to have contraction. Okay? Now, oxytocin also binds to the endothelium. There is a receptor for it here. Okay? And look, I color-coded this receptor. So red receptor here, both the oxytocin receptor. So here, the oxytocin is also binding to the endothelium. Okay, now this is interesting, okay, because look, it upregulates COX. So you folks already had this enzyme, and if you don't remember it, it's okay. I'm going to write it down for you, right? So COX stands for cyclooxygenase, right? And so we did COX and inflammation, right? And there's a family of COX enzymes, but COX for us for right now is fine. And COX, when upregulate, is going to allow you now to make prostaglandins, okay? I love it when the semester repeats because I already know it. Prostaglandins. And prostaglandins is a contractile molecule. It has a receptor and it causes contraction. So what happens is this effect, that's a paracrine effect, that the prostaglandins made in this nearby tissue, endothelium, is going to come to your smooth muscle cells right next door. Hello, neighbor. Bind to its own receptor. Yes? And then also turn on the same mechanism for us to have even more contraction, right? So prostaglandins and oxytocin together are causing a contraction, a summation of contractions where you have contraction, 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 contraction. And then in ejaculation, you can now projectile, right? Get fluid out of the penis or the clitoris or a baby out of the vagina. This is the same mechanism for birth. This is the same mechanism for milk letdown, which is the same anatomy. I have smooth muscle around the endothelium lining of milk ducts. It's all the same, people. So when we say ejaculation, yeah, right now we're talking about ejaculation in males, but we teach it this way because it's the same for everybody. So ejaculation of semen, of ejaculatory fluid in females. Okay. This is the same for birth. Oh my God. I'm excited. Okay. This is the same for milk letdown. All of it. Okay. It's all the same. Oxytocin, prostaglandins, getting calcium into the muscle cell, calmodulin, MLCK, phosphorylate those myosin heads, and you contract. And you get, in order to have a summation of contractions, to actually eject some fluid or a baby out of a tube, you have to have a lot of oxytocin, and we call it the summation of contractions. All right, let's move on. All right, now I want to talk about how we discovered the mechanism of ejaculation. And I always do this in my classes is because it's very important that we as health professionals and as human beings, because we're all human beings in here, it's important that we understand the social aspects of human health. Not only the biology, but the social aspects of human health, okay? So what these researchers did is that they took clitori from medical doctors and bush doctors that perform genital mutilation. And genital mutilation is, there's different degrees of it. You can cut off the clitoris. You can cut off the clitoris and the labia minora. You can cut off the clitoris, the labia minora, and the labia majora. And then you can also sew it up. So there's different levels, type 1, type 2, type 3, right? And genital mutilation is a cultural practice that is performed in some parts of the world to ensure that a woman's virginity is kept is kept as she is presented to her to-be husband. And this process is not for us to judge. Okay, because I know some of you folks are like, oh my God, what? It's not for us to judge, but it is for us to understand that there are many science advancements that stand on the shoulders of oppressed ethnic and low socioeconomic groups. Okay, for example, another example, we discovered how to treat syphilis, yes, by infected people in jail and poor people, women seeking medical care, right? I have a pregnancy. Please help me. Sure. They go ahead and give birth, help them give birth, but then infect them with syphilis and then try giving them drugs that may or may not work. Okay. So a lot of our reproductive science that we understand now was tested without the knowledge, right, of people that were of low socioeconomic standards. Now, some women who have gone through this genital mutilation process have told me that they are proud to have no genitals because they believe in that this is their cultural practice. They're proud to present themselves in this way because this is the way that they were taught is a high standard to present yourself to your husband, right? Now, I've also had students that do not have their external genitalia anymore, but after moving here, they decided not to have this procedure done on their daughters because they saw that now living in America, they see this practice as a type of gender inequality. Okay, so I want to wrap up this lecturette by giving a shout out to all the women out there who have had their external genitalia donated without their consent so we can understand how this process happens. Thank you with much gratitude.